we looked at uh, the derivation of EMF equation of an alternator. So in today's class, let us solve some problems related to EMF equation. All right. So first problem let us consider. Okay, you can copy the question as I dictate. A 6-pole, 3-phase, star-connected alternator has an armature with 90 slots. So I will write down only the important data. Okay. So number of slots is equal to 90 and 12 conductors per slot. So next data is conductors per slot is 12. It revolves at 1000 RPM. And the flux per pole be 0.5 Weber. Okay, so this is the given data. A 6-pole, 3-phase, star-connected alternator has an armature with 90 slots. Conductors per slot is equal to 12. The speed of operation is 1000 RPM and flux per pole is 0.5 Weber. Okay. Calculate the EMF generated. Calculate the EMF generated. If the winding factor is 0.97 and the coil is full pitched. If the winding factor is 0.97, so winding factor is nothing but KD or distribution factor, which is 0.97. Okay. And the coil is full pitched. So Kp is equal to 1. So for a full pitched winding, the Kp value is always unity. Okay. So this being the given data, you can think of finding out the objective. And what is your objective? To find out the value of induced EMF. All right. So to solve this, first what you can do is you can write down the expression for induced EMF. Other day we derived, right, the expression for induced EMF. And what is it? E is equal to 4.44 Kp Kd by F Z phase. So that's your EMF equation. Now, with respect to this EMF equation, you have to just substitute the values. So 4.44 Kp Kd. So you are being given with Kp value and Kd value. So directly you can substitute. Flux value is also given 0.5 Weber. Frequency is you need to calculate, and Z phase you need to calculate. So only the unknowns in the EMF equation are frequency. Okay. So frequency can be found using the formula Pn by 120. We have derived this formula, right, in lecture 2 of module 5. So Pn by 120, which is equal to P is equal to number of poles into N, the speed of alternator, 1000 divided by 120. So frequency is 50 Hz. So frequency is 50 hertz. All right. So frequency is also found. What about Z phase? What is Z phase? What do you understand when you hear about this word Z phase? So Z phase is nothing but conductors per phase. Conductors per phase. So it's a three-phase alternator. So M, let's say M is equal to number of phases. Okay. And what is M? It is equal to 3 because there are 3 phases in a alternator. R phase, Y phase, and B phase. So the count is 3. Now Z phase you can calculate, with a simple formula, something like Z phase is equal to Z total. So total divided by 3 is nothing but Z phase, where 3 is number of phases. So firstly you need to calculate Z total. So how do you find Z total? Do we have any direct information about Z total? No, it is not given, right? There is no data which says something like the total number of conductors are so much. No. Instead, we have been given with this data. Conductors per slot. So first you write down conductors per slot. It is given as 12. Right? So conductors per slot is 12. That means to say, in every stator slots, there are 12 conductors. So what is the number of conductors? So just cross multiply. So therefore, total number of conductors is equal to 12 into slots. 12 into slots. Okay. So what do you get? Z phase as 12 into slots. How many slots? 90 slots. 90. So 12 into 90. Okay. How much you'll get? 12 into 90. Okay. You can write it 12 into 90 only. That's fine. And later you can substitute here. So 12 into 90 you will get it. Okay. So therefore, Z phase is equal to. So Z total you have obtained as 12 into 90. So therefore, Z phase is equal to total conductors divided by 3. So that is 12 into 90 divided by 3. So this is 4 times
360.
Yes, 360. So Z phase is equal to 360. Okay. So once you get Z phase, you can find the induced EMF. So E is equal to 4.44 into kV. What is the value of kV? It's a full pitched winding, hence kV is 1. KD, the winding factor, is given as 0.97. So KD is 0.97 into 5, the flux value 0.5 into Z phase, that is 360. So you will get E. So how much you will get? E 19,000 380.6 volts. 6 volts. So 19,380.6 volts. Okay. Now, can anyone tell me what is this voltage? Line voltage or phase voltage? Is it the line voltage or is it the phase voltage?
Phase voltage.
Good. Phase voltage. Correct. Because Z phase you have taken. Right? Per phase you have taken. Now, if at all, if I ask you to find out the line voltage, what will you do? Which type of alternator is this? It's a star connected alternator, right? So in case of star connected alternator, the line voltage is simply √3 times the phase voltage. So you have to just multiply root 3 with the phase voltage. So root 3 times phase voltage. Phase voltage is 19,038. So as a comment, I can write something like phase voltage. So when you multiply, you get 33,568 volts. So for the given set of data, the line voltage is around 33 kilovolts. 33 kilovolts, very high. So that's your first problem. So this is kind of simplest among the lot, you can say, wherein Kp and Kd values were given. All right. So sometimes they may not give you Kp and Kd value. You may have to find Kp and Kd value using the formula. So other day I have given two formula, right? One for Kp. Kp is cos beta by 2. And Kd is sine n alpha by 2 divided by n into sine alpha by 2. Okay, let's solve some problems in which you may have to determine the value of Kd as well as Kp. All right. So second problem you consider. Right now, a three-phase 16-pole alternator, so P is equal to 16, has a star-connected winding with 144 slots. With 144 slots and 10 conductors per slot. So conductors per slot is equal to 10. Flux per pole is 30 milliwebers. Flux per pole is 30 milliwebers. Distributed sinusoidal. Full stop. Find the phase and line voltages. Find the phase and line voltages if the speed is 375 rpm. If the speed is 375 rpm. So this is the given data. Observe carefully. Please look into the problem data. Okay. Do we have any information about the type of winding, as in whether it is full pitched or short pitched, or the distribution factor? We don't have any information, right? So that means to say, in this particular problem, Kp and Kd values needs to be found. Okay. So you need to determine, or you need to find the value of Kp and Kd, because there is no direct information. Now, in order to find Kp, you have to use the formula something like cos of beta by 2. And beta is defined as the cording angle. Now, there is no data regarding cording angle, right? So, in such situation, what you can do is you can simply assume a full pitched winding. But you have to write it down. Okay, assume a full pitched winding. Lack of data. Assume a full pitched winding. So for a full pitched winding, Kp is 1. Kp is 1. So that's your first decision. Okay, about Kp, which is 1. by assuming a full pitched wind. However, KD you should not assume. KD can always be found from the given data. Okay. So KD, please don't assume with some random number. You will have to find it from the available data. So KD can be found on this. So I can write here something like need to find. Need to find. So let's write KD. So KD is given as sine n alpha by 2 divided by n into sine alpha by 2, where alpha is equal to 180 degree divided by 3m. Okay, 3n. Sorry. And n is equal to slots per pole per phase. Now, n is equal to slots per pole per phase. So you can find out first n value. Okay, slots per pole. Do we have any information about this slots per pole? Yeah, you have number of slots. So write down slots are 144 in number divided by number of poles. How many poles? 16 poles. Okay. Divided by number of phases. So everything gets divided by the phase count. How many phases? It's a 3-phase machine, right? So divided by 3. So if I simplify, I will get 144 in the numerator, and then in the denominator, I will get 16 into 3. So 144 divided by 16 into 3.
3.
4. 4, right?
3.
3, sir.
So alpha is equal to 180 divided by 3 into n. N is 3. So 3 into 3 is 9. So 180 by 9 is 20 degree. So alpha is 20 degree. So once you have alpha value and n value, you can determine KD value. Did you find the KD value? So it is n, that is 3 into n is 3 into alpha 20 divided by 2 divided by n into sine alpha by 2, that is 20 degree divided by 2. So substitute in your calculator and tell me how much you will get in KD value. 0.96 is given in the book. Just cross check and let me know. Is it fine? 0.96 or let's say 0.9599, you may get it. That's fine. All right. So KP and KD values are known to us. With this, we can find out the induced EMF. So from the past experience, that is from the previous example, we have seen that in order to find induced EMF, we need to determine Z phase as well, right? We need to find what is Z phase. So let's try finding out Z phase first. So you have this data, that is conductors per slot is equal to 10. So you can write conductors per slot is equal to 10. Therefore, total number of conductors are nothing but 10 times the slot count. So therefore, total number of conductors is equal to 10 into slots. That is 10 into how many slots? 144 slots. So conductors are 1040. Therefore, Z phase is equal to total conductors, Z total, you can take it as ZT, divided by number of phases. So it is 1440 divided by 3. So Z phase, you will get it as
480.
480. Right. Now you can find out the EMF. So induced EMF is always the phase voltage. Okay, because we derived the expression for phase voltage 4.44 kV kd F5 Z phase, or E phase is equal to 4.44 into kV. We have assumed it as 1 into kd 0.96 into F. Do we know frequency? Frequency we don't know, so you can determine the frequency as well. F is equal to Pn by 120. So number of poles 16 into speed 375 divided by 120. So frequency will get it as 50 hertz. So substitute 50 into plus 30 millimeter, 30 into 10 to the power minus 3 into Z phase 480. Substitute and just let me know the value. How much you'll get? E phase 1534.46. Slight deviation you may get, that's fine. And finally, you can find out the line voltage. So it's a star connected alternator, hence line voltage is √3 times the phase voltage. So √3 into phase voltage, which is 1534.46, which gives the line voltage value as 2657.77 volts. Did you get the answer? Anyone can confirm? Can anyone confirm?
Yes, sir.
Yeah, fine. Fine. Problem number 3. In bracket, you can write problem based on short pitch to winding. Problem number 3. In bracket, you write problem based on short pitch to winding. Rarely they will ask, but you don't know. Right? So please mark this problem as important. Sometimes they may ask a problem based on short pitch to winding. Though we don't study about short pitched winding in detail in basic electrical engineering, still, based on logic, you can solve uh, this particular problem. So copy the statement. A 6-pole, 3-phase, 50 hertz alternator six-pole, 3-phase, 50 hertz alternator has 12 slots per pole. So slots per pole is given. Has 12 slots per pole and 4 conductors per slot. Four conductors per slot. The winding is 5/6 full pitch. Winding is 5/6 full pitched. So this I will mark in red color. This is the important data. 5/6 full pitched. The winding is 5/6 full pitched. Full stop. A flux of 25 milliweber per pole. A flux of 25 milliweber per pole is sinusoidally distributed. In the air gap. Is sinusoidally distributed in the air gap. Determine the line EMF if the alternator is star connected. Determine the line EMF if the alternator is star connected. Okay. So this is the given data. Now, can we assume Kp as 1, just like in the previous problem? No, right? Because they have mentioned about full pitched winding, right? And the winding is 5/6 full pitch. So 5/6 full pitch, in the sense, Kp is not unit. Okay, Kp is equal to 1 only for a full pitched winding. Okay, so you can look at yesterday's class video, in which I had clearly mentioned about the concept of full pitched winding, right? In a full pitched winding, coil span is equal to pole pitch. On the other hand, in case of short pitched winding, coil span is less than the pole pitch. So this is the case actually. So you don't have to worry about coil span, etc., etc. So you know this fact, right? For a full pitched winding, Kp is equal to 1. So that means to say, if your winding is something like 6/6, you would have got the ratio as 1. Right? So 6/6 ratio will get you the value as 1. So this is for a full pitched coil. This is for basically for a full pitched coil. But what is given in the problem? In the problem, they have given the winding is just 5/6 full pitch. 5/6 full pitch. Okay. Now, your full pitched winding corresponds to 180 degrees. So what you can do this simple calculation, something like 6 by 6 corresponds to a full pitched winding, and 6 by 6 is equal to 180 degree. Therefore, 5 by 6 corresponds to how many electrical angles? It corresponds to what electrical angle 5 by 6 winding is going to give. So you can just cross multiply. How much it gives? (180) into 5 by 6 divided by 6 by 6, which is unity basically. 30. So 150 degree. 150 degree. So therefore, chording angle beta. Therefore, chording angle beta is nothing but 180 degree minus angle for 5 by 6. So beta is equal to 180 degree minus. So for a 5 by 6 full pitched coil, how much did you get? The angle as 150. So it is 150. So beta, you will get it as 30 degree. So this is how we calculate beta. So once this beta is known, you can find Kb is equal to cos of beta by 2. That is cos of 30 degree by 2 or cos of 15 degree. Yes. Yeah, cos beta by 2. So how much will you get? Kb cos of beta by 2. Point 958. Point 958. Are you getting it? If you haven't understood, feel free to point out. I can explain this once again. Okay. It's a very simple explanation I have used. Okay. All what you have to do is you have to look for this data. So in the given problem, it is given as 5 by 6 full pitched. And you know that for a full pitched coil, Kb is equal to 1. 1 is nothing but you can look at the numerator and denominator and you can tell when will you get unity value. When you have 6 by 6 ratio. So 6 by 6 corresponds to 1 and that 1 corresponds to 180 degree electrical. So a simple cross multiplication. 6 by 6 corresponds to full pitched coil, which is nothing but 180 degree electrical. Therefore, 5 by 6 full pitched corresponds to how many degrees? So when you cross multiply, you will get the angle corresponds to 5 by 6 winding. How much is it? That is 150 degree. So therefore, the chording angle beta is found by subtracting this angle from the full pitched angle. That is 180 needs to be subtracted from the obtained angle, which is 150 degree. So you will get the beta as 30 degree. And then you can substitute this beta in the standard formula. There is no derivation in basic electrical engineering for this. In higher semester, you will learn. So you have to just by heart this formula. Kb is equal to cos beta by 2. So that will give you the Kb value as 0.958. All right. Okay. Once you have the Kb value, you can easily find out Kd value. So Kd value, you can again should use the formula. So Kd is equal to sine n alpha by 2 divided by n sine alpha by 2, where n is equal to slots per pole per phase, which is equal to slots per pole. You have a direct information, right? Slot per pole is 12, right? So slot per pole is 12 divided by phase. It's a three-phase machine, so divided by 3. So 4 is the value. So n is equal to 4 for this particular problem. And then you have alpha. Alpha is 180 degree divided by 3n, or 180 degree divided by 3 into n, that is 4, right? So you will get the value of alpha. So once you have alpha, you can find out the Kp value. So sine 4 into 15 divided by 2 divided by 4 into sine of 15 degree divided by 2. So how much you will get Kp value? Did anyone calculate Kp?
0.957.
No. Oh, sorry, not Kp. I'm so sorry, man. Kp is cos beta by 2. No? This is Kd. Please make the correction. So sorry. This is Kd. Correct, no? That's the formula for Kd. Kp was the previous value. Please make a correction. So Kd is 0.958. And Kp cos beta by 2 gave 0.966. Okay. Do you agree with this answer? Are you getting the same answer?
Yes, sir.
Okay, good. Okay. So once Kp and Kd values are found, you can also find Z phase, because past problems have taught us that Z phase also needs to be calculated, right, to find out EMF. So Z phase you find out. So Z phase is equal to Z total divided by 3. Okay. And here you can find out. So conductors per slot is equal to 4. Okay. So that implies conductors is equal to 4 into slots. How many slots? Do we have direct data about slots? No, because you don't have slot count. What you have is slots per pole count. So you have been given with slots per pole information, which is 12. But to calculate Z phase, you need slots. So cross multiply. So slots is equal to 12 into pole. So 12 into pole. Poles are 6. So number of conductors are basically 4 into slots. 12 into 6. So how much you will get? Total number of conductors as so that is equal to 4 into 12 into 6. Divided by 3. So 96, right? So Z phase, you will get it as 96. So once you have this Z phase value, you can find out the EMF. Did anyone calculate EMF? So E phase is equal to 4.44 into Kp into Kd into F into phi into Z phase, or E phase is equal to 4.44 into Kp. How much did we get? Kp 0.966 into Kd 0.958 into frequency. They have given beforehand only 50 into flux 25 into Z phase, and Z phase is 96. So you will get per phase voltage. And you are supposed to find the line voltage. So E line is equal to √3 times E phase. So √3 times 246.53. So you will get the line voltage as 427. So this is your problem. So this is what you were supposed to find, and you have found. All right. So that's about problem number 3. Any doubts in this particular problem? Just let me know if you have any doubts. Okay. No doubts?
So instead of 4.44, it will be 2.22 because we are taking Z phase.
Yeah, correct. Because you are taking Z phase, no?
Yes, sir.
And 2.2 is for Z phase. 4.44 is for what? T phase, no?
Turns per phase. Yes, sir.
Yeah. Correct. Turns per phase. But I've been, I think in all the problems, right? I've taken 4.44 only, right?
Yes, sir. The answer was coming double.
Yeah, obviously you'll get twice, right? Twice the answer which I have written on the board. Correct, no?
Yes, sir.
Yeah.
Yes, sir.
Okay. So please change your formula to E phase is equal to 2.22 Kp Kd F phi Z. Okay. So I don't know. Many of them have left. They just join and they just go off. So E phase is 2.22 Kp Kd F phi into Z phase. So please change it in all the three problems. Okay. I cannot edit the video. That is the drawback. All right. In class, I could erase it on the board, but here SEBI said I can't revert back, but I can tell this. Okay. So please change the formula to 2.2 everything. All right. Thanks for pointing out. So everywhere in your notebook, take 2.2. So problem number 4, let's take quickly. Problem number 4. Yeah, slightly different problem, let's say. Write down. A 24-pole turbo alternator. A 24-pole turbo alternator has a star-connected armature with 144 slots and 10 conductors per slot. And 10 conductors per slot. It is driven by a turbine at a speed of 250 revolutions per minute. It is driven by a turbine having a speed of 250 RPM. 250 RPM. The winding has full pitched coils. The winding has full pitched coils with a distribution factor of 0.966. With a distribution factor 0.966. The flux per pole is 67.3. milliwebers. Determine frequency and the magnitude of line voltage second one, output kVA. Output kVA. If the total current in each phase is 50 amperes. If total current in each phase is 50 amperes. It's a slightly different problem in the sense you need to determine the output kVA as well. Okay. Rest all remains the same. So solution. So first you tell me what is kV and what is kV. Tell me. Anyone can tell me. What is kV? I'll wait for your answer. What is kV?
1.
1. Okay. So kV is 1 because full pitched coil. You don't have to determine. And what about KD? Do we have to find out? No, because a direct data is given. Distribution factor is 0.96. So you can directly write 0.96. Directly you can write the KD value. And yeah, that's all. Then you can just start finding out the unknowns. First of all, frequency you need to find. Frequency is Pn by 120. P is 24 into N, 250 RPM divided by 120. Yeah, 24 into 250, how much will you get? Frequency as 50. You get it as 50 hertz. Once frequency is found, you can find out the phase voltage. After phase voltage, you can find out the line voltage. So phase voltage is 2.22 kp kd f into phi into z phase, where z phase is equal to z total divided by 3. Okay, and what is z total? Okay, you can find out z total. The total is equal to, and directly write down, 10 into slots, and slots are 144 divided by 3. So 1440 divided by 3 is your Z phase, and Z phase we get it as okay. It's not calculated, so probably one of you can tell me. $480, right? Is it correct? Z phase 480.
Yes, sir. 480.
Right, that's all we need. Next, you can find the phase. So 2.22 into 1 into 0.966 into F into 5, 67.3 into 480. So we'll get E phase. Once you know E phase, you can find out EL. It's a star connected alternator. The star connected alternator. So line voltage is √3 times the phase voltage. So you can tell 3463.8 volts E phase and almost 6000 volts. Okay. $5,999.5 volts. That's your line voltage. So second part is also found. Now the second part, that's about the output kVA. Okay. How will you find output kVA? What is the formula for kVA? So output kVA kVA is the apparent power, yes. So S is equal to √3 VL into IL. Or you can also find S as 3 into V phase into I phase. Any formula you can use. √3 VL IL, or you can use 3 times V phase into I phase. Okay. Where VL is equal to EL. And that is 5,999.5 volts. And IL is equal to I phase is equal to 50 amperes. So it's a star connected system. In case of star connection, line current is equal to phase current. So that is IL is equal to I phase, that is 50. So just multiply voltage, current, and you can also multiply √3 or 3 with respect to line and line and phase value. You can find S is equal to, let's say I'll take the line values. So I need to take the multiplication factor as √3. So it is √3 into 5999.5 into 50. So roughly I will get around 519. S is equal to 519.5. You may not get the exact value, even the approximate value. Few of you may get 518 or 520, it doesn't matter. So in and around 590 you get, that's more than sufficient. Okay. So that's about problem number 4. So actually that's it from module 5A, that is alternators. Okay. So the next class, what I will do is there's a small theory left out, that is advantage of stationary armature over rotating armature. So that I will consider, and I'll also solve 1 or 2 problems from different textbook. Let me see. All right, and kindly be prepared for 3-phase AC circuits quiz. So shortly I'll be conducting a quiz on 3-phase AC circuits. All right. That's all for the day. Thank you so much. Yeah, tell me. Anyone has doubts?